Okay, good morning. Today we will be talking about the fourth topic of the software modeling and analysis module, right? So today we will be covering the basic concepts and practicals and theoretical aspect of use case diagram. Right. So as the recap, so far we have covered our lectures about on decomposition, and so in here in the decomposition we have talked about either both of techniques, algorithmic and object oriented, and we have discussed about the characteristics of the objects, especially states and behaviors, and also we have talked about the programming paradigm, and then we have discussed about the diagram overview of a software project, right? So as the introduction for the today's session, so first thing is we know uh, any of software is developed according to a by following different steps, right? So the usually that particular steps belong to a happening in a cyclic way, and that's why we are telling it as software development life cycle. So here is a summarized view of the phases in delivering a software or the steps. So the first thing is initiation. So in the initiation is the point where the business need is raised. So for example, if people can't manage the available health data by using current normal implementation, so one can think why we can't manage our health information or the monitor our health information using blockchain. So that is the initiation point, or that is basically the business need raising a business need. So once you have the that set of business needs, then you will start the requirement gathering, do the requirement gathering. So in there, people will interview different stakeholders and explore the different existing systems or the similar system in the world, and or they might ask the client can take the client requirements also, and then we have the based on the gathered requirement, we will develop different documents like software specification document. We basically analyze what are the engineering aspects of the system and the system concepts. So based on that specification, we will start the designing part of the software or the project. And once the design part is done, so we can start the implementation. So once the implementation is either complete or ongoing, we can do the testing and gradually integrations and so. And so once the system is deployed to the client's environment, we can continuously, we can maintain the software. So this is the basic phases of delivering software. So the reason I have put this slide in here, it's because in the software modeling, we are more focusing on these requirements gathering and especially the specification part, right? So you have a set of requirements. So based on that, you try to analyze and develop this different design diagrams in order to implement, in order to support your implementation, right? So that's why I just put slide in here. So when the finalizing requirements, so usually the most prominent or the initial requirements come from the customer or the client. So that can be interviews, meetings, questionnaires, uh, documents, reports, etc. And so these requirement has to be stabilized or the freeze before the designing. It means you have to stop. Actually, you have to finalize the requirements. These are the requirements that we are going to address in this particular phase, right? You can't design a software or design a diagram for changing requirements. So you have to freeze in a agreeable form, agreeable level, right? And so in that case, development team will usually development team along with the customer can finalize what are the requirements we are going to freeze. And then we have to communicate those set of requirements. So in that case, we have to do a communication. And the problem is, in a project, we have high technical people and low technical people. So the usually customer will be the low technical people and the software development team will have a high technical literacy. So in that case, since we have two different technical literacy levels, so we need to have a method of communication that could understand by both of the customer and the software development team. So when it comes to the finalizing the requirements, the use case will be the best communication method, right? So we will go now forward. Yeah. So the why use case diagrams are required. So the first thing is development team should be able to understand what the business needs or wants, because based on that, people will development team will develop the software. And so basically the business want represent the requirements, right? So when the requirements are nicely presented, the development team can get the basic understanding. And also to get the system users involved in the early stages of system analysis and design. So usually it's better to have customer involvement at the early stages of the development from the, actually we are saying like from the step one, right? We don't need to so when the customer involvement is at the last stage of the software development, so there can be so many conflicts due to the miscommunications or misunderstanding, etc. So in order to avoid that, so we have to involve the system users at the early stages of the analysis and decide. So the use case, when we developing the use case diagrams, so these people will involve in these kind of sections, right? And to get some sort of overview of the product or the project that we are going to develop or the software, we can use the use case diagram. So basically use case diagrams will show a big picture of the given system based on the user perspective. Who are the users and what are the actions or what are the activities that can done by each and every user will represent in the use case diagram, right? So since the users are the outside world to the system, so use case diagram can represent or can illustrate what the outside world wants to do with the system, right? So in use case diagram, it's like a representation. Graphically, we are representing the interaction between the system and the user. So in the use case diagram, we eliminate the word user and that word was replaced by the actor, right? So the user and actor is also same. So usually a full use case model or full use case diagram will have two parts. So the first part will be a diagram. So the diagram will basically graphically illustrate the different relationship between the system and the actors, right? So and then apart from the diagram, a full use case model will have a document which is describing each and every use cases in detail. So the use cases will basically represent what are the actions that a system can do, right? So since it's more focusing on the possible actions that could do from the system, so it will automatically create some sort of semi-formal model of the functional requirements, not about the non-functional requirements, right? So before we develop the use case diagrams, so we need to analyze and define what is our scope, what are the external interfaces, and if the system have different cases like scenarios, and for each and every scenarios there can be different reactions. So these reactions we have to analyze and write it down in somewhere, right? So as a common advice, when you are drawing the use cases, you don't think about how the code will be there. So you should never ever think about the implementation. So basically, when you develop a use case, the technical implementation is not affecting to the diagram. You only think about the system users or the actors and possible actions or the use cases or scenarios, right? So so we will now discuss about the basics of use case diagram. So now we will try to figure out what are the use case actors and those kind of technical terms, right? So usually we have four components in the use case diagram. So actor, use case, interaction, and system boundary. So these interaction can either association, inclusion, or extension. So we will discuss these interactions in detail, right? So the first important component of the use case diagram is actors. So Usually, actor will represent a system user, right? And so whenever it comes to the word actor, we usually think that would be a one person, a single person. But when it comes to use case diagrams or in this software world, an actor can be a single user or group of users or even a system, right? So for example, in an e-learning system, student will be an actor, right? For a e-learning system, entire academic staff will be a actor. So the academic staff is a group of users, right? So that can happen. It can be either single user, group of users, or even a system. So if your system is providing, so interacting with the e-learning system, for example, let's take a fingerprint system. So we can, so if the fingerprint system is interacting with the e-learning system by providing lecture attendance and student attendance or whatever attendance, so this can so in that case fingerprint system will act as a actor. So the symbol is this kind of figure, right? Instead of writing actor letter here, we will simply write student, teacher, etc. Okay. So then second important component of the use case diagram is use case, right? So use case usually represent a activity. So that activity should be a complete activity, not a partial one, right? And that activity should be taken from the user perspective, not the system or other perspective. Only we are talking about actor's point of view. Actor के पैත්තෙන් තමයි හැම වෙලෙම activity එක define වෙන්න ඕනේ use case වල. Right? So there can be so if there is an actor, that particular actor can do more than one use case, right? And in the use case diagram, usually there are many use cases, right? So when it comes to the learning management system, so participating for an online quiz is a one action that can be taken by student actor. So in that case, participation for an online quiz will be a use case. So the symbol will be oval shape, and we have to write the use case name inside of that oval shape, right? So then we have the association. So the association will be the simpler relationship. So we basically show the connection between each and every actor and the corresponding use case by a straight line. So that particular straight line called as the association, right? So attempting to an online quiz will be the association. So the symbol is straight line, right? And then we have the system boundary. So the system boundary will represent the boundary between the physical system and the actors who interact with the physical system, right? So we have these actors, we have these use cases, and use cases and actors are connected by straight lines called association. So we need to separate actors and the use cases So for that, we will use the system boundary. So the symbol will be a rectangle shape. So in this lecture series, I will take a different example. So it would be a hydroponic garden system. So the hydroponic garden system is using water instead of the soil, and in the water there would be different nutritions will be supplied to the plants, and so that is happening in the hydroponic gardening system. So as a requirement of the system, let's assume the client or the customer has given the requirements of the system. So if we read those things, a hydroponic garden system consists with 3 types of users, right? Gardener, nutritionist, and plant analysis. And so when we consider in the first requirement, so it's clearly shown that we have 3 different system users. And when it comes to the gardener, so the gardener should be able to manage the garden, maintain the storage tanks, and view the growth report. So gardener will able to do 3 different activities or the use cases. So manage the gardening, maintain storage tanks, and view the growth reports. And also at the same time, to maintain the storage tank. So when the gardener is performing the maintaining the storage tanks task, the gardener should be able to view the growth reports. So before he is going to maintain the storage tanks, report should be checked or the viewed, right? However, to manage the garden, he may look at the growth report if it is required. But when it comes to managing the garden, so the report, growth report can be viewed if it is required only, right? So that is the actions or that are the system privileges that available for the gardener. So when it comes to nutritionist, so that particular user should be able to update the crop encyclopedia by looking at the report related to the growth of plants. So third point will shows the third requirement will shows the what are the actions that could be done by the nutritionist. So he will be able to update the crop encyclopedia. So that would be the action. And before updating the crop encyclopedia, nutrition should be have a look at to the growth related reports. And for the plan analysis, so he will do the managing the growing plan, update crop encyclopedia, and view growth reports. Right? Further, to update the crop encyclopedia, he should view the growth reports of the plant. So if the plan analysis are updating the crop encyclopedia, so he should view the growth report before doing that. So that is the whole 4 requirements given for this hydroponic gardening system, right? So let's try to understand different cases and the different interpretation of this case, and we'll try to draw a use case by yourselves, right? So you can have the what we call lecture slides, right? I have uploaded, so you can download by yourself, and you can, so then you can refer to this particular slide, right? So when we do drawing, so before drawing, I have said we have to analyze and define what are our actions, who are the actors, etc. So first thing is we will understand who is the actors of the system. So we have three actors: gardener, nutritionist, and plan analysis. So, and then we have to understand what are the actions that could perform by each and every actor. So as I explained in the previous slide, so the gardener, nutritionist, plan analysis can these set of activities, right? So if we move forward little bit towards the use case concept, so the actors of the system will be the use case diagrams actors, and each and every actions that could perform by the each and every actor will represent the use cases of our use case diagram, right? So then, so can you try by yourself how to draw? So these are very easy things, right? Use case diagram එක බොහොම සරල කතන්දරයක්, right? Right. So since you guys are in the final year, so that should be a easy one, right? Anyway, in the tutorial session, we will do more exercise, right? So yeah. So if I So I have three actors. One, so usually we draw the actors first, and then you can write whatever the actor names, right? So we have gardener, nutritionist, and plan analysis, and then you can draw the use cases, right? So we have view, report, right? And manage garden, update encyclopedia. So likewise, you can do it. So when it comes to this manage gardener, so that action is performed only by the gardener. So in that case, we simply draw something like this, right? So likewise, so I think this is right. So then once you have done, so you will simply draw the system about, right? So if you draw it, so this should be your answer, right? So when it comes to this action list, right? So you can see view growth report is done by all three users. So in that case, we don't need to repeat the view growth report action. So we can simply use one single use case and connect each and every actor. And then we have that this update the crop encyclopedia. So that is done by nutrition and plan analysis. So this that use case is also we can reuse. So then we have this kind of diagram, right? This is very easy because when you learn the sequence activity, so then there is some sort of things to think. So this is just you understand who are the actors and who are the possible actions. Then you just draw it, right? No worries. So we have mentioned that we in a full use case model there are what we call documentation part also. So when it comes to the use case specification, so it will explain in a written format about the each and every use case, right? So as the requirement specification, we develop a small document for our use case diagram. So it basically provides a detail of the functionality that the system will support and describe how the actors will use the system in order to obtain a specific results of value. So usually a use case specification will contain the use case name, use case description, optimistic flow, and the pragmatic flow. So let's talk about these sections, right? So if I take this use case name, maintain storage tanks, right? So we can, if we elaborate the purpose of this maintaining storage tank use case, so this use case usually provides the ability to maintain the filling levels of the content of the storage tank. So, this allows the actor to maintain specific sets of water and nutrition tanks. So since our system belongs to a hydroponic gardening system, right? ජලය මාධ්‍ය කොටගෙන වරා කරන system, right? So in there we can have a action called maintain storage tank. So these storage tanks can be either storing water or different fertilizers or nutrients. Right? And these storage tanks will have levels, right? So let's assume if one water tank is have 5 meters height, and so when it comes to the half of the 5 meters, so it would be in the let's assume let's say something like this, right? So if I draw it, so this is our tank, right? So let's assume this is having water, right? And let's say it's 40 liters, right? So we can simply divide our storage tank into 4 different levels. For example, this will represent quarter. So then this will be half, and this will be 3/4, right? Likewise. So we can add. So these kind of levels could be there. So in the maintained storage tanks, we can fill the storage tank with different levels. Yeah. And then, so we will talk about this optimistic flow. So the word optimistic represent the positive or the usually positive meaning, right? So when we talk about the optimistic flow of the use case specification, right? So that the optimistic flow will represent the if the things work normal way, then we don't have any alternative. So our flow is optimistic. So it's a sort of straight line. So then we can so based on the 100% happy case or the positive case, so we can list down what is the action flow. So for example, if the all things are okay, so in the maintained storage tanks use case, so the actor examines the levels of the storage tank's content, and then actor determined that tanks need to be refilled. Normal hydroponic system operation of storage tank is suspended by the actor. Actor select the tanks and set fill levels for each selected tank. Step E through G are performed. So E will be if the tank is heated, the system disable heaters. Since the heaters are disabled, so the safe temperature will be arrived, and then the system fills the tank. When tank is filled, if tank is heated, the system enables the heaters, and then it will reach the operating temperatures after resume the normal hydroponic system operation. So these would be the optimistic flow. So when it comes to the pragmatic flow, it means if the things work unusual way, these would be the alternative flows. So it means something like if else case, right? So when it comes to the so basically pragmatic flow is representing the alternative ways, right? So when we write the pragmatic flows, so we will write in this format. So we will state the condition 1. So then we will write the condition 1, and then we will explain what are the parts for first condition, and then we will start writing the second condition, and we will explain what is the flow of the second condition if the second condition triggered. So likewise we can write. So when it comes to condition 1, so there is insufficient material to fill tanks to the levels specified by the actor. So in here you can see since it is the optimistic flow, if the all things are okay, right? So refilling amounts are available in the garden. We don't need to go to a go for a shopping or go to the purchasing, right? But in this case, first condition is if the materials are insufficient. So then this would be our set of actions, right? Okay. And then, so So far, can you understand what I have talking about? තේරුණාද? Okay. And then we have a special case in use case, right? So, okay. We have another special case. So, for example, let's assume. So in here, yeah, in here. So if I take the gardener, so in the second case, so the second sentence, it's saying at the same time, to maintain the storage tank, he should first be able to view the growth reports. So it implies that, right? So in a simple term, in order to maintain the storage tank, whatever person who is doing the maintain storage tank should be view the growth reports. Without viewing the growth report, the gardener or the whatever responsible actor cannot maintain the storage tank. It's something like you should be registered to the system in order to log in. අනිවාර්යෙන් register වෙලා තියෙන්න ඕනේ login වෙන්න නම් system එකට. In this case, in order to maintain the storage tank, that particular person should view the report first. Right? So that is a one case. So it means before executing one action, another action should be performed. And that action is another action is essential. That is a one case. And then we have the other way around of the case one as the case two. So in order to perform a use case or the action by the actor, another executing of another use case is optional or not compulsory, right? So the third sentence of the Gardner requirement will illustrate that particular case. However, to manage the garden, he may look at the growth reports if it is required. So it means gardening manage run. So in order to do the managing the garden, gardener can view or not growth reports, right? See the how English used, right? So when there is the compulsory situation, in the inside of the sentence we have used should, but in the if the case is not compulsory or the optional case, right? So may look if it is required. So it will tell that executing the second use case is not compulsory, right? So since we have this kind of relationship in between of use cases, so we have to have some sort of mechanism to illustrate this relationship. So we can have, in the use case, we have include and exclude use case concepts, right? So then nutrition actor using so he's having the crop encyclopedia, updating the crop encyclopedia, right? So before updating the crop encyclopedia, view report should be executed, right? So in the include use case, we represent the mandatory or the compulsory operation, compulsory execution of another use case activity before executing the given use case, right? And when it comes to the gardener doing the maintaining the storage tanks, so the gardener should execute the view report use case. So in that case, how are we going to represent? So we simply use the include use case, include relationship, right? So yeah. So your diagram, the first diagram that you have drawn is not having this include relationship, right? So once you have basically draw the simple use case diagram, then you can design the these include and exclude use cases, right? Since this BU growth report use case is mandatory or the compulsory to do before this maintaining storage tank and update crop encyclopedia. So you can see this relationship is a mandatory case. So we can, so in that case, include is the syntax. So we simply write the include in this format and make carefully, you should understand the arrowhead will be pointed to the compulsory use case. අනිවාර්යෙන් කළ යුතු use case එකට තමයි arrowhead එක point වෙන්නේ. පැහැදිලිද? So ඔයගොල්ලන්ට නිකන් ඒක හිතෙන් read කරද්දි include එකක් සාමාන්‍යයෙන් අපි අඳිනකොට ඔය read කර mind එකෙන් read කර තමයි අපි සාමාන්‍යයෙන් අඳින්නේ. ඕනම diagram එක. So when you since maintain storage tank, before maintaining the storage tank, view growth report should be done. So this particular use case is have to, before that we have to go to this one. So that's why this arrowhead is there, pointing to the mandatory use case, right? I think you are clear. And so the exclude will represent the optional case, right? If wanted, one can execute the another use case if only needed, right? So in that case, okay, my mistake, I have added the wrong diagram. So I will correct this one, right? So if we go to the okay, yeah. Yeah. So when the managed garden activity is done by the gardener, viewing the growth report is not compulsory, right? So in that case, I know that I have to use exclude relationship, right? So I will draw it for you. So exclude. But the case is the view growth report action is optional for managed garden. So since that one is optional, you simply point towards the main use case, not the optional use case, right? So that is how you going to draw the exclude use case. Okay. And then we have another concept called generalization. So in the generalization, right? So use cases can have common behaviors that another use case can be used, right? So for example, if we take this example, right? Purchase ticket contains the basic steps necessary for purchasing any tickets, right? So you have a superior use action called purchasing ticket. So in this world, when we have to purchase a ticket, there is a common steps. But when we go to the specific purchasing specific tickets, like for a let's say film, let's say sport event, etc., right? So even though we are doing the purchasing ticket process or the ticket action or the use case, there would be a slight differences, but majority of the steps will be common with the purchase ticket, right? So in that case, we can use the generalization, right? So yeah, and we can so usually in a use case diagram, we do not duplicate same use cases, right? So in that case, we can use either include, exclude relationships. So and the generalization. So you can see we did not repeat BO growth reports for 2 times. We simply use one use case and we reuse it whenever we need it. So if I represent how we going to draw this generalization in a use case, so we can actually generalize, do the generalization for both actor and the use case. So I will show you an example. So if I'm doing the actor generalization, so let's assume for a user management, so for a LMS or the learning management system, we have student and lecturer, right? So we have simply, so this will be student, and let's assume this is lecturer, right? So we have login, and let's assume view marks. So usually let's assume view marks can be only done by student, right? So add marks can only done by the lecturer, but the login use case can be performed by this student and the lecturer also. And let's assume we have this registration use case as well. So that is also can done by these two, right? So you can see this login use case and the registering to the system use case are both common to student and the lecturer, right? So since the same set of activities are done by student and the lecturer, our diagram is a sort of mess, right? So what we are doing is, right, we simply, yes, we have our student, and then we have our lecturer. So we have view marks, right? So view marks is done by only the student, and we have add marks. It is only done by the lecturer. And also we have this login and the registration, right? So we know these two are common to both lecturer and student. So what we are simply doing is we introduce the generalization, right? So we create a superior or the superior user or the superior actor. Let's assume user. So we can simply give something like user, right? So user will do these two activities. And then since this user's actions are both common to generalized to student and the lecturer, so we can simply do the generalization. So it will be something like this. So whenever you read your diagram, right? So the way that you are reading is basically, so student is there. If we take the student, right? So student, so it is basically common, doing the common user activities, login and the registration. So whenever you implement the code, so you have that understanding. So student is doing the login and the registration, but this line, this green color line is not represented in the diagram, but that is represented here by the generalization, right? That is what is happening. So this is user generalization. And also when it comes to the use case generalization, right? So if we take that purchase tickets use case, right? So we have that one. And we have movie and then movie match, and let's assume musical show, right? So since the purchase ticket is happening only the, so when it comes to the movie, the price or the obtaining method would be different, but the same. We have to pay, we have to give our names, etc. Right? So what we can do is we can simply generalize by right. So this is how we do the use case generalization. Okay. Yeah, that's all for today's session. Do you have any questions to clarify? මොකුත්ම තේරුන්නේ නැද්ද නැත්තම්?